So hello everyone, welcome back to the lecture. In this particular lecture, we'll be talking about projection matrices for a vector. Alright, so let's begin with this concept of projection matrices. Alright, so when we talk about projection matrices, you should first of all remember that a projection of a vector on another vector, suppose I project vector x on y. So projection of x on y is given by x, okay, x transpose into y, okay. I'm sorry. The projection is given by x into y multiplied by x transpose divided by x transpose into x. And simply this x transpose into x is the dot product of x with itself. So this is the norm of x, or the length of x. So you can also write it as x dot y into x transpose by the norm of x. This is basically the projection or the shortest distance of x on a vector y. You can also project in the same way on a subspace, on a column space, on any other vector space. You can do these projections. Now, to get the projection matrix for any projection, there is a simple rearrangement of terms that we need to do. Let's pick up this formula because this notation is better. We are doing it in terms of dot products, though both of them mean the same. So when you have the projection, you have, again, I'm writing this formula, x into y into x transpose by x transpose into x. Now this formula and examples of this I have taken up on projection videos. You can watch the playlist and check this, okay. Let's simply do a change, okay, because we just have to find the projection matrix for the vector x, because x is what we are projecting, right? So we'll have to just find it for x. So just remove y from the equation and put y here. So this becomes x into x transpose by x transpose into x into y, okay. This is what we get by rearranging. So this is simply a rearrange, and on rearranging, what do we get? We get this. Now the projection for x, we don't need anything of y, we just want to find the projection matrix for x. So to get the projection matrix, just take whatever terms are there with x. So what you get is x into x transpose by x transpose into x, which is simply the norm of x, and this is the P of x, which is written as the projection matrix of x, okay. So this is basically what the projection matrix talks about. Now another way of representing this is you do x into x transpose into x inverse x transpose. This is again the same thing, right? This is dividing by x transpose into x. So if I just put it in the numerator, this will become inverse. 1 by 2 is simply 1 into 2 inverse, right? That's the same thing. So you can also find notations in books like this, but this means the same thing. You are actually doing x into x transpose divided by x transpose into x, right? So this is the simple thing that you should understand. Now let us take some properties. Let's talk about some properties of the projection matrix, okay. Let's talk about some properties. The first property is that in projection matrices, the square of the projection matrix is equal to the projection matrix itself, okay. Why this is happening, we will understand in diagrammatically later, but this you should remember. The second thing you will remember is the transpose of the projection matrix is equal to the projection matrix, and you already know when a matrix and its transpose are equal, these are called symmetric matrices. So the projection matrix is a symmetric matrix always. There are many properties as well, but the third and the very important property again is the rank of the projection matrix is 1. So you will find the rank of the projection matrix to be 1. Alright, these are the important steps, the properties that you need to remember. And now what we will do is we will take a vector, for example, okay, and we will also we'll also find the projection matrix. Now before that, one more final thing that you should remember. This whole term is my projection matrix, okay. This is P. So if I want to write the projection of x on y, which I wrote initially using this original formula, I wrote it like this, but now I want to write this in terms of the projection matrix. Can I do that? Simple, you can do that. This will simply be projection matrix of x into y. The projection matrix of X contains all the terms we have here, X into X transpose by X transpose into X, and you multiply it by Y, you simply get what we had earlier, and that's how you get it. So one way of getting the projection of a vector on another is through the normal formula. The second way is you first find the projection matrix and then multiply it with the vector Y. You will get this result, right? Okay, so let's take a vector for example and let's check the projection matrix of that vector. So the example that I take is I have to find the projection matrix for V, which is 2, 1, 3. So this is my V. So what is my formula? Again, you remember the formula. This is X transpose X into X transpose divided by X transpose into X. This X transpose into X is simply the norm of X, which is the square root of the squares of the components, x1 square till xn square. This is the norm of X. We have discussed a video on norm earlier. If you have any doubt, you can watch that video. So let's find out the norm of X first. The norm of X is simply the square root of 2, 1 and 3, and you add them. So this is 4 plus 1 plus 9, which is 14. Okay, you square root them also, but for the projection matrix purpose we don't square root, so you can just take it as norm square and you'll get 14. Okay, so if you square root also the things are same, but for the simplicity in projection matrices we don't square root it, so your norm will be 14 in this particular case. Let's get the vector X into X transpose. So X is like V, X means you can call this X here as well, 2, and what is X transpose? Just make this row into the column into a row, you get this. This is a 3 cross 1 matrix, this is a 1 cross 3 matrix, so in the result you're going to get a 3 cross 3 matrix. Okay, let's multiply. So every row on every column, so 2 into 2 is 4, 2 into 1 is 2, this is 6, 1 into 2, 1 into 1, 1 into 3, 3 into 2, 3 into 1, 3 into 3. You get this, and this is just divided by 14, so simply this means you are multiplying it into 1 by 14, okay, which is the norm here. This is a scalar multiplication, and this is your projection matrix, right? So you're in the end, you just divide all the elements by 14 and that will be your projection matrix. Okay, so let's do that as well to just make things even clearer. So 4 by 14, 2 by 14, 6 by 14, 2 by 14, 1 by 14, 3 by 14, 9 by 14, 3 by 14, 6 by 14. So this is your projection matrix. So this is P of X. Alright, now let's check up the properties. The first property that we have here is the symmetric part. Let's get the transpose. So P transpose. So make the rows into columns. This is 4, this is 2, this is 6. I am not multiplying by 14. I am just taking it like this because multiplying by 14 will make no difference. So 1 by 14 I am taking outside only, just to make things easy for illustration. 2, 1, 3 and 6, 3, 9. And you see indeed that the transpose of the matrix and the matrix itself are same. Now you can check this yourself at home that the P square will also be equal to P. Just multiply P with itself, you'll get P square, and that will be also equal to P. And finally you should do this as well, that we should check the rank. Let's see what the rank is. So again, we are not multiplying by 14 at the moment. We'll check it without this multiplication. So you first of all divide the first row by 4. This is 1, 2 by 4 and 6 by 4. Similar is 2, 1, 3, 6, 3, 9. Then you subtract 2 times of R2 here and 6 times of R1 from R3. And when you do that, you will see you get only zeros here, okay? So let's do that. You will get 1, 2 by 4, 6 by 4 and 2 minus 0, this is 0 and 0. So what am I doing here? R3 minus 6 R1 and R2 minus 2 R1. This is what I'm doing here. So 1 minus 4 by 4 is 1 is 0. 3 minus 6 2s are 12 by 4 is 3 minus 3 is 0. Similarly 3 minus 3 is 0. And 9 minus 6 2s are 12 by 4. 9 minus, no, this is not 9. What this is the 6 times. So 36 by 4 is 9. So 9 minus 9 is 0. So when you know this, you know that rank of this matrix is 1. So rank of P is 1. Right? Rank is what? Rank is the number of non-zero rows. There is only one non-zero row here. So it is 1. So that means all the properties that we listed above for projection matrices. There are other properties as well, but these are the most crucial properties that we have to remember for a projection matrix. and these are satisfied. The square property I have not done here because that's a very easy thing. You just have to multiply it with itself. So you can check that at home as well, and you will get that the square of this matrix will also be same as the projection matrix itself. Okay, so this is how we can get the essence of projection matrices, and I hope this video made this concept clear. Again, if you want to get the projection of this vector on any other vector, you just multiply this projection matrix with the vector v, whatever vector you want to project, and you will get that as well, right? So that's all for this particular session. We will meet in the next session and we will discuss some other concepts related to linear algebra and machine learning. Thank you.